Hi again. This video is going to show some examples of the chain rule for differentiation. In particular, we're going to look at the way to write the chain rule down, where the derivative of y is written dy dx, and it's broken down as a product, dy du times du dx. We're going to look at three examples here in just a moment. I thought you might want to write them down. We're going to calculate the derivative of these three functions. First, we have a polynomial raised to the fifth power, so that's a composition. Second, we'll have tangent squared of x, which means tangent of x times itself. And then third, we'll look at a different composition where we're taking tangent of the little polynomial x squared. So the angle is x squared. So first we notice there's a difference between examples 2 and 3. Here the function tangent is squared, and here x is squared and then plugged back into tangent. Okay, to do this derivative, we're going to refer to a theorem called the chain rule in most textbooks. Suppose g is differentiable at some value x. And suppose y is a function of u, and it's differentiable at any u equals g of x. The composition function y equals f of g of x is differentiable at x. And its derivative can be written one of two ways. Either it can be written with Leibniz notation, where we label the derivative dy over dx, and we calculate the derivative in two pieces, and we take the product dy du times du dx. That's what we'll use in this video. Just for completeness, though, I'll show you this other notation, and you can compare it. Again, we're taking the derivative of a composition function, f of g of x. The derivative of that composition will end up being a product. You might see that it's f prime times g prime, but more specifically f prime is evaluated at g of x and then multiplied by g prime. Okay, let's take a look at our first example where we have a polynomial raised to the fifth power. Oops, sorry about that flash on the screen. Okay. The first thing a person needs to do when looking at a composition function and trying to take its derivative is to break it down what function has been substituted in another function. Well, I see I have a polynomial to the fifth power. So that innermost function I'm going to label as the function u. That polynomial is going to become u. The outer function is what's being applied to the inner function. So we're going to label y as u to the fifth. U is the polynomial, and that means y is the polynomial to the fifth power. Okay, now we look at these separately. We're going to take the derivative of u with respect to x. That's just a power rule, and we get 6 times x. Plus the derivative of x, which is 1. And then second, we take the derivative of y with respect to u. Well, we have the power function u to the fifth, so its derivative is 5u to the fourth. Okay. So the first version of the chain rule told us to label our derivative dy dx, and to write down the product dy over du times du dx. Well, dy du was 5 times u to the fourth, and we'll multiply that by du dx, which is 6x plus 1. Okay. Now the notation tells us we want our function to be just a function of x. U is a placeholder. From the very beginning, we said u is going to take the place of the polynomial 3x squared plus x. So let's substitute back in. Wherever we see a u, we substitute our original polynomial. And that dot was supposed to be multiplication. So our final answer, dy dx, is 5 times the polynomial to the fourth power times 6x plus 1. Okay, example 2. It may remind us of example 1 a little bit. Here it is. Example 2, y equals tangent squared x. This superscript is attached to the function tangent, and it should be interpreted as tangent x times itself. So 2 factors of tangent x. In this example, we see that the inner function, which we're going to label u, is that trig function, tangent of x. The outer function, what's being applied to tangent x, is the squaring function. So y is u squared, where u was tangent x. Okay, now we go back and take the separate derivatives. The derivative of tangent is secant squared of x. And dy du, we use the power rule and get 2 times u. So recording our final answer, the derivative of y with respect to x is a product. dy du times du dx. Okay, so looking back at our calculations, dy du is 2 times u, and du dx is secant squared of x, becomes a product. And u was a placeholder from the beginning. U took the place of the function tangent of x. So our final answer should be written 2 times tangent of x times secant squared of x. And those parentheses I used, those were just for convenience. We can write this as the 3 factors, 2 times tangent x times secant squared. Okay. Final example for this little video. We put it up here where we can compare it to our first example, or excuse me, example 2. Let's compare these again. As we come across these composition functions, we really have to pull them apart. So in the previous example, we were squaring the trig function, and so we could think about it this way. But in example 3, we're going to apply the tangent function to x squared. And, you know, we may want to put some parentheses around x squared to help us keep that in mind. Okay, so in example 3, what is the inner function? Okay, that inner function would be that the angle, the expression for the angle, that inner function will be x squared, and we'll label it u, which leaves the outer function to be the trig function. So we'll just call y tangent of u. It's tangent of something. And in this example, du dx is 2 times x. dy du is secant squared u. And our final answer, dy dx, will be the product secant squared of u times 2x. Excuse me, I got out of the peripheral vision of the camera. And simplifying this, secant squared of u, we go back to how u was defined. U is x squared. So we need to write down secant squared of x squared, the whole thing multiplied by 2x. Now that's an okay answer. That is the derivative. It's my convention. It's what I like to do. I like to bring this polynomial up front so that it doesn't somehow get confused with this angle x squared. And I can see that I'm taking 2 times x times secant squared of x squared. And we can stop here. Or someone else might like to write 2 times x times secant of x squared squared. That's the meaning of what we have written here in the third line. Okay, I'll have you take a look at that on your own. Maybe play it back and try them on your own. And be looking for another video. Next video, we'll write this chain rule just using a little bit different notation. So in the next video, we'll have f of g of x. The outermost function will just remain f. The innermost will be g. And its derivative will be f prime of g of x times g prime of x. It's equivalent to what you saw in this video, but uses different notation. And you can choose whichever one you like.